Hi, my name is Takuzo Ganre. I am a former A-level student and I graduated high school with straight A stars, and I'm here to help you do the same, or if not, just to make A-level maths a little less challenging for you. So in this video, we'll be looking at simultaneous equations. The syllabus point that we're focusing on states that we should be able to solve by substitution a pair of simultaneous equations, of which one is linear and one is quadratic. So to learn about simultaneous equations, we will use two examples. So in the first example, our linear equation is x plus y plus 1 equals 0, and our quadratic is x squared plus y squared equals 25. So let's start by making x the subject of the formula in the linear equation. So this becomes x is equal to negative y, negative 1. Now let's substitute this expression of x into the quadratic equation. And so this is our quadratic, and x here has been substituted by negative y, negative 1. And then we expand our bracket here and it becomes y squared plus 2y plus 1. Now let's simplify that whole equation and we should get a quadratic equation. And here's our quadratic equation. Y squared plus y minus 12 equals 0. Then we solve our quadratic and get our two roots, which are y equals negative 4 and y equals 3. Now that we have the y values, we can also find the x values. So we go back to our linear equation and notice that here we have y. Substitute that y with the values we have found. And so let's start with when y is negative 4. When y is negative 4, we substitute y with negative 4 and we simplify, we get x is equal to 3. And then we can represent this as a set of coordinates. The x value is 3 and the y value is minus 4. Then let's evaluate x at y equals 3. So substitute y with 3 and then simplify, you get x is equal to negative 4. Again, we can also represent this as a set of coordinates, negative 4, 3. So it means that our final answer is two sets of coordinates, which are 3 minus 4 and minus 4, 3. Let's move on to the second example. Our linear equation is 2x plus 3y equals 7, and our quadratic is 3x squared is equal to 4 plus 4xy. Again, let's make x the subject of the formula in our linear equation. So it becomes x is equal to 7 over 2 minus 3 over 2y. Let's go back to our quadratic, and everywhere where there's an x in our quadratic equation, we want to substitute with this expression. So that's what we have done here. Then now let's simplify by expanding the brackets and we should end up with a quadratic. And so here is our quadratic. 51y squared minus 182y plus 131 equals 0. And if you solve the quadratic, you get the y values, which are y equals 131 over 51 and y equals 1. Now to get the x values, again we will go back to the linear equation and let's start with y equals 131 over 51. Where there's a y, we'll substitute y with 131 over 51, and this gives us x is equal to negative 6 over 17. Again, we can represent this as a set of coordinates. This is not correct. It should be our x values negative 6 over 17 and our y value is 131 over 51. Now we do the same for when y is equal to 1. We go to our linear equation and where there's a y, we substitute y with 1 and we simplify and get x is equal to 2. So we can represent this as a set of coordinates. X is 2 and y is 1. So that means our final answer will be 2 sets of coordinates. So that is how you solve simultaneous equations. And if you want access to this PDF, I've left a link down below in the description. And also, if you'd like to access more resources on my website, there's also a link below in the description. Thank you for watching.